Let me first explain to you how the class will go today. The first thing we'll do is I'll just quickly explain to you how to approach studies or anything that you like. Not only studies, but whatever you like, whatever you want to do, how to approach that. So quickly I'll explain. I will not waste too much time there. After that, we will discuss quickly the concept of proportionality. Now, proportionality is very important because in Ohm's law, you will hear the word proportional, isn't it? And then we will start with Ohm's law, and there we will see how much we have to discuss or how much time we have to spend on current, voltage, and resistance. And in that resistance, we will also try to learn the cause of resistance. And wherever necessary, we will be solving problems based on these concepts. So today's class, we will try to complete these things. So what should be the approach to studies? Well, can you see this side? I have listed some personalities. Though they are experts in different fields, all of them had something common, and that is they all loved what they did, right? They all loved what they did. They were ready to spend time. And thus, students, I request all of you that it's important that we spend time first. Like today, you are spending time with me. So first, you have to be ready to give time to what you want to do. Once you give time, obviously, if you spend time properly, you will understand the concept. And once you understand the concept, you will improve. And once you improve, once you do something good, you will feel happy about that, right? And once you feel happy about that, you will be giving more time. And thus, this cycle will keep continuing till you become expert as one of them. So, that is the whole idea. Give time. If you give time, obviously, you will understand things. Once you understand things, you will improve, you will do something good, and then you will feel happy about it. So, the main thing is to give time. Don't run away. Because see, you have to be happy about what you do. Sometimes when you are a cricketer like Virat Kohli, right? When he scores a century, he feels very happy. But when he gets out, obviously he will be sad. But that doesn't mean he will leave. He will run away from cricket. He will try to learn what mistakes he did. And from those mistakes, he will try to learn again, try to correct those mistakes. So don't run away when you fail in something. Try to give time to that. Try to learn from someone who already knows those things. Try to be with somebody who already knows the subject or the concept. And then slowly with time, 100% you will do better and you will become expert in whatever field you choose to be. Okay. So with that, let us start today's class. So when I take two quantities, let's say y and x are two quantities, any two quantities. And if I say y is directly proportional to x, if I say y is directly proportional to x, then what does it mean? So first thing is to understand what is the meaning of y directly proportional to x. So some students are saying, don't know, sir. Okay. Anybody else? Ryan, you would like to answer? Very good. This is what many students are saying. If x increases, y also increases. Beautiful. So what many students are saying is when x increases, y also increases. That is the meaning of directly proportional. Now, let us take one example. Let us say y is pocket money, x is father's salary. Okay. So x is father's salary, y is my pocket money. Now, let's say my father's salary right now is 1000. So if my father's salary is 1000 and he gives me a pocket money of 10 rupees, so I'm very happy, right? Now, tomorrow my father does something good. So his salary is doubled. Doubled of 1000 means how much? 2000, isn't it? Now, if my father comes home and says, son, today my salary is doubled. So I'm going to increase your pocket money. and I am going to make it 40 rupees. 40. Oh, good father, right? No problem. Now tell me, did you see X increased and Y also increased? But in this case, we cannot use the word proportional. So you can see here that when X increases, Y also increases, isn't it? But in this case, we cannot use the word proportional. We cannot use the word proportional. Why? Because here X increases 2 times, but Y increases 4 times. So in that case, we cannot use the word proportional. When can we say proportional? If when my father's salary became doubled, which is 2000 from 1000, how much should be my pocket money? Can anybody tell me? How much it should be? How much should be my pocket money so that if this is doubled, this also should be doubled. 20, isn't it? And therefore, only in this case, we can use the word proportional. Now, one thing you notice, in the first case, what will be the ratio of y by x? What will be the ratio of y by x? Can you check? Y is 10, x is 1000. So what is the ratio? 1 by 100. Correct? Now when my father's salary is doubled and my pocket money is also doubled, what will be the ratio of y by x? 2000 by 20. 0, 0 cancel. 2 1s are 2. So here y is, sorry, 20, not 2000. So y is 20, x is 2000. What is the ratio? 0, 0 cancel, 1, 2, 2 cancel. So 1 by 100. Am I right? So what did you notice? In both the cases, the ratio is same or different. So here it is 1 by 100. Here also it is 1 by 100. Only then you can use the word proportional. So students, the main idea, please write down in your notebooks. Please write down in your notebooks. If y is proportional to x, this is the symbol for proportional, directly proportional. This you must be knowing, right? So if you see anywhere y is directly proportional to x, then always remember y by x, this ratio will remain constant. This ratio will remain constant. Clear? And sometimes we write that constant as k, but you can use any other symbol, that doesn't matter. But normally we write here as some constant as k. So please make a note of this part, that whenever y is proportional to x, y can change. You can see y can change. X can also change, but the ratio should not change. The ratio should remain constant. Okay. Then let us now go with Ohm's law. So I hope the concept of proportionality is clear, students. Again, let me repeat once. When y is proportional to x, y divided by x will be always constant. So y will be equal to some constant times x. So this you try to remember. Okay. Now come to Ohm's law. Imagine you have some bulb and I want current to flow in the bulb. What I want to flow? Current. Current should flow in the bulb. The bulb should light. Now, if you just wait, do you think the bulb will light? No, right? Why it will not light? Well, what is the definition of current? Current is basically how much charge flows, this is the charge, divided by how much time it takes. So if you have any area through which charge is passing, and if you divide the charge crossing this area by the time taken, that is called current. Okay. So now in these wires, these are wires, remember. So if I zoom this wire, zoom, what will you see? Well, this wire, let me zoom. So I will show it quite big, okay, like this. So this is this wire. Now inside this wire, what is this wire made up of? Please type in. It is made up of what? No, the wire is made up of copper, but inside the wire, what is there? Inside the wire. No, current will not come now, Nisarga. How current will come now? In wires, we don't get current. No, when you buy wires, do you get current with the wire? When you buy wire, you don't get current with the wire, right? So everything is, acha, in chemistry, do you remember that Dalton's theory? That he said everything is made up of what? All the matter in this universe is made up of atoms. Very good. So this wire, like everything else, is made up of atoms. Now these atoms are bonded to each other because it is solid. If it was air, then if you do foo like this, those atoms will spread here and there. But for wire, if you do foo like this, the atoms will not go here and there, isn't it? So those atoms are bonded to each other strongly. So let me represent those bonds by these lines. Don't worry, I will come to Ohm's law. Let us first understand the concept of current. Okay. So this structure is called lattice. Now, if this wire is a conductor, like you told, example, copper, then the last electron of this atom, we call the last electron as valence electron. That electron will become free, free, free from the atom because it is very loosely bonded. So room temperature, thermal energy will be there in the room, right? So because of the collisions of the air molecules, the last electron, which is very weakly bonded to the nucleus, that last electron will become free. So once that atom loses the last electron, please listen carefully. Once the atom loses the last electron, that atom will become what? Positively charged or negatively charged, or it will remain neutral? Very good. It will become plus. So in a conductor, all these atoms will lose one or two electron and it will become positively charged. We call this atom after it loses electron as positive ions, and this dot represents electron. Now these electrons are free, right? So they will move around, but because they are moving inside a wire where there are many ions, they will keep colliding with the ions, and because of that collision their motion will be, what do you think? It will be in a straight line, or they will keep changing the direction and it will be random. Because it keeps on colliding, the motion will be random. It will not be like all the electrons moving in one straight line. So therefore students, if I consider some area like this here, some area like this, tell me, if I say two electrons are going this side, then how much I should say this side? How many numbers should go this side if it is random? Random means all directions are equally allowed. No direct, you cannot be partiality, no partiality for any direction. All directions are equally allowed. That means if I say two electrons are going this side, how many electrons I should say is going this side? If all directions are equally allowed, very good, two only. That means if two electrons go this side, two electrons go this side, then total how many went this side? Total, no one went this side because these two will cancel this two. This part is clear, students? So two electrons going this side will cancel the flow of two electrons going this side. That part is clear how it got cancelled? Otherwise, I can give you some example to understand. So on. Okay, fine. So if all of you understood, let me not give the example. So students, Because the motion of electrons is random, again, write these important points. Since free electrons, motion of free electrons. So since motion of free electrons is random, if two electrons go this side, two electrons will go this side also. So therefore they will cancel each other's effect. So the current will be right now how much? What will be current? If two electrons this side cancels two electrons this side. If two you want to cancel with another two, cancel means you have to subtract. So what you will get? Zero, right? Because the directions are opposite, no? We have to subtract. Clear or not clear? Okay. So the current will be zero. So right now, I hope all of you understood that even if electrons are moving in the wire, they are moving randomly and therefore they don't create any current. Electrons inside these wires are moving randomly. So no current. So if I want current, what I should do, all of you know, we should connect a what? Battery. So what this battery will do? This battery will apply a voltage. Sometimes call it potential difference. Because of that, this end will be positive, this end will be negative. So now, can you see those free electrons inside will be attracted to this plus? So can you see these free electrons inside will be now attracted to this plus? Because they are negatively charged, right? Electrons are negatively charged. So because now this is plus, the electrons inside will be attracted this way. And this negative rod of the battery will repel the electrons. So this is how now electrons will start moving in the wire because of this attraction. Let me give example. See, imagine you were moving randomly in in a jungle. Let's say so there is a jungle and lot of trees, and you keep colliding with the trees, and your motion is random. Now suddenly a very strong wind comes this side. Now what will happen? Your motion will be now more this side or this side. The first side because of the wind. So think of this battery as applying a push. So this battery, due to its voltage, it applies a push on these electrons. And before, how many electrons were crossing this side? Two. How many was crossing this side? Two. Right? But after connecting battery, what will happen? Because they are all attracted this side towards the positive, if two are going this side, more will go this side. This example you understood. Now also they are colliding, so don't think the collision has vanished. Don't think collision will vanish after applying battery. One more time I will say, don't think collision will vanish after applying battery. Collision will still be there, but because of the push that the electrons are getting from the voltage, because of that push, now more electrons will go this side. Therefore, before, remember, they cancelled each other. But now, if 2 is going this side, more than 2 will go this side. This part is clear because of the attraction from the battery. So now the current is no longer zero. Current is now not zero. Not zero. Here current was zero. So students, I hope you understood. Due to this voltage applied by the battery, electron starts moving this way, and thus you get current in the opposite direction. So current is due to this voltage. Now, have you heard in your school, your teachers must have told you that if electrons move this way, current in the wire we show this way, ulta. Have you heard of that? That if electrons are moving from minus to plus, current is actually from plus to minus. Now, the reason for that is historical, students. I don't want to spend time on that right now. If you want, I can make a small video and share with all of you in the group. But today's class, I want to solve some problems. So I don't want to go to the history of why it happened. So is it okay, students? I will not try to explain to you because when I was student, I used to think, Arey, if current is due to electrons like this, then why do we take current this way? Wherever electrons are moving, there only you take current. Arey, if river is flowing this way, river, water, if water in the river is flowing this way, the current of the river we say this way only. So wherever water is flowing, there only we say current is there, water current, right? But in case of electrons, we don't do like that. So I used to think why it is like that. Then I came to know the reason is actually historical. So I'll try to make a small video and share. Today we will focus on problem solving. Okay. Fine, students. So if you have understood all this, now how does Ohm's law come? How does Ohm's law come? Very simple. Who applied the push on the electrons? Who applied the push? The battery. But how battery was able to apply push? Because battery has voltage. So voltage results in push on electrons. So if you increase the voltage, that means you are increasing the push. You are increasing the wind. If the wind increases, you will move faster or slower? Faster, obviously, that I don't need to ask you, right? So if I push more, then you will move faster. So electrons will move faster. Electrons move faster. And if they move faster, time taken will be less. Time taken will be less. Right? If you do something fast, you will take less time. And what is current? I told you, all of you, what is current? I told charge by time taken. So if time taken is less, current will be more because they are what? Proportional? Inversely proportional. So that means if you forget this part, forget this part, forget this part, forget this part, forget. If you forget this part, then what do you see? When voltage increases, current increases. And that is the whole idea about Ohm's law. Yes or no, students? And that's why in Ohm's law we say voltage is proportional to current. I hope all of you understood this part. So when you increase the voltage of the battery, you are increasing the push on the electrons. And as the electrons in the wire feel more push, they will move faster. And if they move faster, they will take less time. So current will be more. It's like if river is flowing fast, we say, oh, very high current, what? Very high current today, like that, isn't it? If river is flowing very fast, the current is high. And if river is flowing very slow, the current is less. So when electrons move faster, current will be more. So if voltage is more, current is more. If voltage is more, current is more. It means they are directly proportional. And if they are directly proportional, that is what is called Ohm's law. But in the starting of the class, I told you proportionality, right? What I told you, check your notes. When y is proportional to x, y divided by x was what? Constant. Very good. So if voltage is proportional to current, it means voltage divided by current will be constant. Constant for a given bulb. If you change the bulb, then this constant will change. Students, wait. When I said constant, what does it mean? It means y can change, x can change, but y divided by x cannot change. So when you change voltage, current will change. But the ratio matlab voltage divided by current, that will remain constant. Now in physics, we give names, right? So let us do naam current. What current? Namkaran. So we have to do some Namkaran for this constant. And all of you already know, I think, the name given to this constant is resistance of the bulb. Resistance of the bulb. So let us start our first question. So two students are there. This is, let's say, let's give some name. Ravi and Shankar. So two students are there, Ravi and Shankar. They are doing experiment by taking some device. Let me show you the diagram. So some device they have taken and they are applying a variable voltage. So when I put this kind of arrow, it means it is variable voltage, variable. Okay. And with the help of voltmeter, he measures the voltage, and with the help of what? How will he measure current? With the help of ammeter. With the help of ammeter, he measures current. So here you put ammeter in series. This plus means this should be plus, this plus minus. Anyways, so he gets voltage and current data after doing experiment. So here voltage is, let's say, 1 volt. Let me write only numerical value. 1 volt, and this is, let's say, 5 amperes. This is 2 volt. This is, let's say, 15 amperes. This is 3 volt, and this is, let's say, 25 ampere. This is the data collected by Ravi. What is the data collected by Shankar? How he got the data? He got the data from this experiment. This was not given in the question. Not given. I gave you to just explain, because you may be thinking, no, how he got voltage and current. So he must have done some experiment. So that is not given in the question. Now Shankar also did experiment, and he found that this is 1 volt 5 ampere, and when this is 2, this is 10, when this is 3, this is 50. You have to answer whose device. Remember, Ravi used one device and Shankar used another device. So whose device is ohmic device? Ohmic. Ohmic device matlab it obeys Ohm's law. So you have to answer which device, or I should say whose device. Whose device obeys Ohm's law. And such a device is also called ohmic device. Such a device is also called ohmic device. So try to answer. So how to check? How to check whether really it is obeying Ohm's law or not? Simple. Just now I told you, to check whether it obeys Ohm's law or not, you have to check V by I should be constant or not. So how should you answer in exam? How will you answer in exam? Very simple. For Ravi, V by I, if you calculate, in the first case, it is 1 by 5. In the second case, it is 2 by 15. 2 by 15 will be, 1 by 5 will be different from 2 by 15. Third case, it will be 3 by 25. So if you calculate these values, they are not same. But in the case of Shankar, if you calculate V by I in the first case, you get 1 by 5. In the second case, 2 by 10. But what is 2 by 10? 2 ones are 2, 2 fives are 10, 1 by 5. What is V by I in the third case, third measurement? 3 by 15, right? Which is again 1 by 5. So in whose case V by I is constant? In case of Shankar. In case of Shankar, V by I remains constant. So therefore, This answer is Shankar. Because Ohm's law says V by I should be constant. Is it clear, everyone? Artha aita. See, this question some people think is difficult. Now, I will tell you what some students thought. Some students thought both obeys Ohm's law. Why they thought both obeys Ohm's law? Because they thought current increases, voltage also increases. Yes or no? See, current increases 5, 15, 25. It increases. Voltage also increases. And most of the students, what they think? They think when Ohm's law says when voltage increases, current increases. So since many students think this one, they think both of them obeys Ohm's law. So they will tick the wrong option. Okay. So be careful about that. So it's not about when Y increases, X increases. That is not the condition for proportional. The condition for proportional is Y divided by X should remain constant. Okay. One more question we will do. So let's do one more question. Here they've given a graph of voltage versus current. And Shankar did again experiment. Let us do same Shankar and so Shankar and Ravi both are again doing the experiment, but this time they are plotting the graph in the experiment. And I hope all of you know how to plot graph, right? To plot graph, you need equation between y and x, isn't it? So if I give you equation, you can find the values of x, you can find the values of y for different values of x, and then you can plot the graph, right? So Shankar did one experiment and he got one graph, and Ravi did one more experiment. So this is Ravi's graph. This is Shankar's graph. You have to answer whose device has more resistance. Whose device has more resistance? Some people answer this question by using slope. But I was thinking without using slope, just by using Ohm's law, we will try to answer. Okay. So let us again remember what is Ohm's law. V equals to I into R. So what will be R? What will be I? V divided by R. Correct. Now look carefully. They are asking from this graph how to know which device, whose device has more resistance. Very simple. Take one voltage coordinate. Matlab, these are voltage, right? This axis is representing voltage. So choose some voltage here. Choose any voltage here. You can choose here also, no problem. Now see what is the current for Ravi's graph. For this voltage, what is the current? This is the current for Ravi's graph for this voltage. This is how we plot graph, no students. All of you know, right? If this point has x value 2, y value 3, then this point is 2, 3. These things you know, right, students? Okay. So take any one voltage and now check what is the current for Ravi's graph. For Ravi's graph, this is the current. For Shankar's graph, oh my God, this is the current. Oh, this is Shankar. So which current is more? This much is the number. This is the current for Shankar. This is the current for Ravi. So which is giving less current? Ravi's graph or Shankar's graph for same voltage? This number is less or this number is less? Ravi's current is less, no? So if current is less, resistance will be more. If current is less, resistance will be more because this time I kept voltage constant. So if you keep voltage constant, same battery, apply same battery, but take different bulb. So the bulb with more resistance will allow less current. Artha aita. So this time what I did to answer this question, I assumed let us keep voltage constant. Then what Proportional says these two are what? Proportional. Inversely proportional. So the bulb with more resistance, the device with more resistance will allow less current. Since Ravi has less current, it means resistance for Ravi is more than resistance for Shankar. Everybody clear? Now, sometimes what they will do, they will change the graph. IV graph. So this time here current, here voltage. That is the wish of the person who is doing the experiment. Okay, you cannot force it. So now let us say two girls are doing experiment this time, and this is the graph for Sita and this is the graph for Geeta. Now tell me whose resistance will be more. I mean, not whose resistance, who is using device with more resistance. Apply the same technique. Take some voltage and check which one will give. Somebody said Sita. Okay. So take one voltage and check which one will give less current. Whichever will give less current, that will have more resistance. Since voltage is now on x-axis, let me choose this as voltage. So voltage is fixed now. Everybody clear, no? How I took this voltage. So I am choosing one number, any one number, your wish. Now tell me, for Geeta, what is the current according to the graph? This is the current according to graph for Geeta. And for same voltage, what is the current for Sita? S. Now tell me everyone, which current is less? Geeta's current or Sita's current? Current is less for which one? This current is less or this current is less? I hope I did correctly, right? This is for Geeta. So for same voltage, Geeta's graph is giving this current. For same voltage, Sita's graph is giving this current. So Geeta's current is less than Sita's current. Therefore, the resistance of the device used by Geeta must be greater than resistance of the device used by Sita. The answer is Geeta. Clear? So we'll stop for today, students. Thank you.